Halogenation in aniline. This is today's lesson. In this lesson, we are going to learn halogenation reaction and mechanism of halogenation. So, let's begin. First point is halogenation reaction of aniline. Let's write the reaction. This is aniline or aminobenzene. This is also called phenylamine, which is colorless oily liquid. Its boiling point is around 184 degrees Celsius. When aniline is treated with bromine solution in carbon disulfide or carbon tetrachloride, then aniline forms orthobromoaniline and parabromoaniline. This is formed as byproduct. This reaction is carried out at room temperature at around 25 degrees Celsius temperature. As amino group is electron donating group towards benzene ring, that is why ortho positions and para position become electronically rich. That is why electrophile from bromine molecule, that is bromine cation, attacks ortho position and para position. That is why orthobromoaniline and parabromoaniline is formed. Again, when aniline is treated with bromine solution, here solvent is water, which is polar solvent, but in this case carbon disulfide or carbon tetrachloride. These solvents are non-polar solvents. So this is the difference. Here non-polar solvent is used, but in this case polar solvent is used. When polar solvent is used, then electron donating capacity of amino group increases. That is why electron density increases at ortho and para positions to the highest level. That is why cation produced from bromine molecule attacks ortho positions and para position at a time to form this compound bromine, here bromine, here bromine, that is 2,4,6 tribromoaniline, which deposits as precipitate, and here as well HBr is formed as byproduct. These are the halogenation reactions of aniline. Here aniline with bromine solution, here solvent is non-polar solvent carbon disulfide or carbon tetrachloride, then aniline forms orthobromoaniline and parabromoaniline. But when aniline is treated with aqueous solution of bromine, then polar solvent water increases electron donating capacity of amino group. That is why ortho positions and para position become electronically rich to the highest level. That is why bromine cation produced from bromine molecule attacks ortho positions and para position at a time to form 2,4,6 tribromoaniline, which deposits as precipitate. This is the halogenation reaction of aniline. Let's see mechanism of the reaction. Mechanism of the first reaction. Here, step 1, bromine molecule, when it comes in contact with aniline, then electron repulsion occurs between phenyl group and bromine molecule. As a result, bromine molecule suffers a heterolytic fission to form bromine cation and bromide ion. Step 2, aniline molecule now interacts with bromine cation. Here, pi bonds can be shown in this way. Bromine cation attacks ortho position because ortho positions and para position become electronically rich due to the presence of amino group. Amino group activates benzene ring through positive mesomeric effect. So, bromine cation attacks ortho position to form this entity, hydrogen, here bromine. As bromine is positively charged, inside benzene ring there is created positivity, which is now called sigma complex. To vanish this positive charge, covalently bonded electrons of carbon-hydrogen bond move towards benzene ring, and as a result, this hydrogen gets freed as proton, and this compound is obtained, NH3, here bromine, that is orthobromoaniline, and this hydrogen gets freed as proton. Step 3, this proton combines with bromide ion, which is formed at step 1 to form hydrogen bromide as byproduct. In this way, orthobromoaniline is formed. Following same mechanism, parabromoaniline is formed. This is the mechanism by which aniline forms orthobromophenol and parabromophenol. Let's see mechanism of the second reaction. Now, mechanism of the second reaction, in which aniline reacting with aqueous solution of bromine forms 2,4,6 tribromoaniline, which deposits as precipitate. Let's see mechanism of the reaction. Here, because of the presence of polar solvent water, aniline becomes active towards electrophile. That is, polar solvent increases electron donating capacity of amino group towards benzene ring. In this way, aniline, here polar solvent water is used. Oxygen is negatively charged, hydrogen positively charged, this hydrogen positively charged. That is, it's a kind of polar solvent. Here, electron density increases around oxygen. That is why electron repulsion occurs. Because of this repulsion, electron density increases around nitrogen. Ultimately, nitrogen donates electrons towards benzene ring. As a result, ortho positions and para position become electronically rich. That is, electron density increases at ortho positions and at para position because of the presence of polar solvent water. Actually, because of this electron repulsion, and that is why bromine cation produced from bromine molecule attacks at a time ortho positions and para position to form this compound bromine, here bromine 2,4,6 tribromoaniline because of the presence of polar solvent water. But in this case, carbon disulfide, which is non-polar solvent, even carbon tetrachloride, this is also non-polar solvent. Non-polar solvent cannot affect the amino group like polar solvent water. That is why for the non-polar solvent, aniline forms orthobromoaniline and parabromoaniline. This is all about halogenation in aniline. No more today. Thank you very much.